Most real-world problems exist in 3 dimensions, not 2, so trigonometry problems in 3 dimensions get a little trickier. Here's an example. Let's say you're standing on the shore and you're looking across a river to a cliff. Now you can take some measurements if you're a surveyor to figure out the height of the cliff. So a surveyor would measure a line, in this case 25 meters long, along the shore, and then take some angle measurements at each end to the base of the cliff across the river. And then also take an angle of elevation measurement to the top of the cliff. So with a distance, these 2 angles to the bottom of the cliff, and this angle of elevation to the top of the cliff, you can figure out the height of the cliff. So this distance across the river, I'm going to label that as D. And the height of the cliff, I'm going to label as H. And it's important for this problem that anytime you're dealing with height, you're dealing with a right angle. So the cliff is 90 degrees to the river. Whenever I tackle a 3D problem, I try to separate the diagram into different parts. In this case, I'm going to draw a top view and a side view. So I'm going to start with the top view, solve for D, then I'm going to switch to the side view and solve for H, the height of the cliff. So my top view is going to be up in the sky looking down on this triangle. So we're using the triangle that has the 25 meters along the shore and the 25-degree angle looking to the base of the cliff and the 30-degree angle looking to the same point on the base of the cliff. So there's my top view triangle. My side view is going to be if I was standing in the river looking at this triangle with the base along the river and the height along the cliff. So there's my side view triangle. So now I'm going to do the same tactic that I did in 2-dimensional problems. I'm going to solve for the shared side first. In this case, both triangles share side D. So I'm going to solve for D. So I'm going to look at the top view triangle. I know 30-degree angle and I know the 25-degree angle, so I can automatically figure out this third angle because all 3 angles have to add up to 180 degrees. So if I subtract the 30 degrees and the 25 degrees from 180, I end up with 125 degrees. I now know an angle and its opposite side, so I can use the sine law. So I'll set up my sine law ratio, rearrange the equation to isolate D, and plug that into my calculator and solve. So I get a distance of 12.9 meters across the river. So now when I solve for the height of the cliff on my side view, I can use that value of 12.9 meters for D. So one thing I notice is this triangle is a right triangle. That means I can just use my primary trig ratios, sine, cosine, or tangent. So if I look at SOHCAHTOA, my acronym, I have to think which one do I use. So here's my reference angle. I want to know the opposite side, and I know the adjacent side. So I'm going to look for the ratio that uses opposite and adjacent. In this case, tangent uses opposite and adjacent. So I'm going to use the tangent of 50 degrees. So the tangent is equal to the opposite, which I've labeled as H, over the adjacent, which is 12.9. So I isolate for H, and I solve for h, getting an answer of 15.4 meters. So to answer this question, I would say, therefore the cliff is 15.4 meters tall. So to sum up, when dealing with three-dimensional problems, it's sometimes easier to separate it into more than one diagram, like a top view or a side view. Then solve for the shared side first and go from there.